Let me start with something you've almost certainly run into. You're building something with AI, you write out a super detailed prompt, and what comes back is still wrong. It just keeps drifting off. You probably think either the model isn't smart enough or my prompt wasn't good enough. The article I'm relaying to you today says it is neither. This article pulled 1.9 million views in its first 24 hours. Let me give you its conclusion up front. The prompts, the context, the instructions you hand the AI, that is a map, and the place the task actually happens, your codebase, the real constraints, the real environment, that is the territory. The AI drifts because you're handing it a map that is drawn wrong and telling it to march ahead. First, who wrote this? Thariq Shihipar, technical staff at Anthropic, a YC-backed founder, and widely seen as one of the people who understands Claude Code the deepest. He did something that surprised a lot of people. A guy with zero video editing experience cut the entire Fable launch video by himself, using nothing but Claude Code. What got him there wasn't some fancy prompting trick. It was one thing he did the whole way through. At every uncertain point, he found his own unknowns first, and then he started working.
Before the relay, 3 disclosures. 1. Thariq works at Anthropic, so at the end of the day, this article is promoting Claude, and every example is Claude. 2. His sample size is 1, his own case. It is a good story, not a study. 3. What I'm passing to you has been through a layer of Chinese retelling. It is secondhand. Take the method as a reference. Don't swallow it whole as some ironclad rule.
Keep those 3 in mind. Now let's dig in, because there is real substance here. Start with the most counterintuitive line. The stronger the model, the more expensive your unknowns. Back when models were weak, if the output was wrong, you blamed the model. Fair enough. But models are now strong enough to handle most of your tasks. So when it is still wrong, odds are your map and the territory are just too far apart. There is one line from Thariq that stuck with me. He said, Fable was the first project where he truly felt the bottleneck on the quality of the output was his own model. Notice, that is his own understanding of the problem, not the AI model. We're always waiting on a stronger model. But once the model actually is strong enough, you realize what is holding you back is the edge of your own understanding of the problem. So what exactly is an unknown? He splits them into 4 types, and that is the backbone of the whole article. Type 1, known knowns. The stuff you wrote into the prompt, the stuff you told it explicitly. That part it executes faithfully. Type 2, known unknowns. Things you know you haven't figured out yet. Like I haven't nailed down the boundaries of this feature, or I'm not sure which approach fits better. You know it is there, and you still have a chance to resolve it before you start. Type 3, unknown knowns. Things you actually know, but take so much for granted that you never wrote them down. You have preferences, you have gut instincts, and you only know whether they're right once you see the result. It is that feeling where the AI hands you something. You look at it and know it is off, but you can't say why. Type 4, and the most dangerous unknown unknowns. The pit you never saw coming. You don't know it exists, so you never deal with it ahead of time. By the time you find it, you've usually gone a long way down the wrong path. So Thariq lands on a conclusion that really stings. The best AI users aren't necessarily the ones who write better prompts. More often, they just have fewer unknowns before they begin. And that is a skill you can train. How do you train it? He breaks the whole process into 3 phases: before implementation, during, and after. The most important is before you start, which is exactly the part most people skip. For before you start, he gives 5 moves. I'll run through them quickly. Grab the ones you can use. Move 1, the blind spot pass. You don't know what to ask because you don't even know the question exists. So just have the AI find your blind spots for you. Tell it who you are and how much you know about this area first, so it can surface the blind spots that actually matter to you. Thariq did exactly this. He didn't know the first thing about color grading, but the video needed it. So he had the AI teach him the things about color grading he didn't know. Figure out what the problem is first, then start. Move 2. Have it give you several completely different directions. When you know the result you want but can't describe it, like a visual style or a certain tone, don't make the AI guess. Have it hand you 4 or 5 completely different directions at once, and you react to which one's right. Your reaction is itself information. Move 3. Let the AI interview you. You know there are fuzzy areas, but you don't know where to start asking, so hand the asking over to it. But remember to give it a priority order. Prioritize the questions where your answer would change the overall direction. A lot of the time you can't think it through on your own, but the moment it asks, you instantly know what you want. Move 4. Give it a reference. Sometimes it is not that you don't know what you want, it is that you can't put it into words. So stop struggling to describe it, and just throw it a reference. For people who write code, the best reference is source code. Point it at a library that already pulls off the effect you want, let it read the source, and re-implement it in your own project. That is way more accurate than describing it for ages. Move 5. Have it draft an implementation plan first. The point isn't how complete the plan is, it is separating the decisions you have to make from the execution it can handle on its own. Put the calls you need to make up front, and hand off the pure execution entirely. Then you only watch the few decision points you might change, instead of reviewing every last detail. Okay, so you've done all your before you start homework. Does that make execution foolproof? Nope. During implementation, things you didn't foresee always crop up. The core of this phase isn't eliminating unknowns. It is staying calm when you hit one. Thariq's tool for this is called a deviation log. Have the AI keep a log file. When it hits an edge case, instead of stopping to wait for your sign-off, it picks a conservative way to handle it, records the decision, and keeps moving. That way it stays consistent, and the log becomes a better map for your next time. Once the task is done, there are 2 more steps. Step 1, package the output, the prototype, and that deviation log into a write-up someone else can understand. This isn't just for other people, it forces you to figure out what you actually had the AI do. Step 2 is a little odd. It is called the quiz. Have the AI write you a report first, laying out what it did and the thinking behind it, and then have it quiz you. Only if you get the answers right does it prove you really understood, instead of just skimming it and hitting merge. He says the quiz is a digestion mechanism, not a trust issue. Honestly, letting the AI test me, the first time I heard that, it threw me for a second too. But think about it. How many times have we had the AI change a whole pile of stuff, glanced at it, decided it looked fine, and shipped it? Ask you what changed and why, and you've got nothing. And when something breaks, you don't even know where to look. So what does all this resemble from history? Let me give you a few reference points, and you weigh them yourself. 1. The line "the map is not the territory" is nothing new. The semanticist Korzybski said it back in the 1930s. Zoom out, and this is just the scientific method. Form a hypothesis first, then go verify it. The second reference point, like sending scouts in a war. A good commander doesn't charge ahead with an old map. They send people to scout the terrain first, then decide how to move. But there is a third view too, a bit of a cold splash. This might just be old common sense, repackaged in AI language. Except that AI has made the cost of drawing your map blind expensive and concrete for the first time. Finally, my own take. I genuinely think this method is useful. Its biggest value is turning that vague frustrating. The AI keeps drifting into a problem you can actually diagnose. Next time it drifts, you don't have to blindly rewrite the prompt. You can ask yourself, which type of unknown did I mishandle? Did I not write it in? Did I know it but never resolve it? Did I have a hidden preference I never voiced? Or did I simply not know that PIT existed? Different disease, different cure.
Let me nail this down again. A method is a method, but don't forget those 3 disclosures. 1 case, 1 company's promotion, and secondhand through me. It is a handy framework, not gospel.
Fair point. Let me boil it down to one line for you. AI is an amplifier. It amplifies your understanding, and it amplifies the blind spots in your understanding. If you haven't figured out what you want, no model, however strong, can save you. The good news is your unknowns aren't fixed. The longer you work in a field, the more those unknown unknowns slowly turn into known unknowns, and then into known knowns. Your map gets closer to the territory each time. For the next 2 years, I'm watching one thing. Whether this habit of finding your unknowns first, of running a blind spot pass first, just gets built into the AI tools themselves, so it becomes something they do for you by default, instead of something you have to remember to do. Next round, I'll keep relaying for you.